Eskimos company participated in the development of a high-powered computer model to simulate flow coming through different types of gravel packs and different types of well screens. What precipitated this study was the fact that over decades and decades of research, not just on our own, but reading reports that others have done, combined with looking at case studies, side-by-side wells of different types of construction, different types of screen types, and different gravel packs, that we noticed that there was not a significant change in efficiency based on certain parameters, and one of them being the amount of open area in the well. So you look at the screen, and what does the screen contribute to the actual efficiency of the well? In the past, it may have been overemphasized, saying if you just go with this particular type of screen or a particular type of open area as a minimum, that's going to be satisfactory for an efficient well. But what we found out through several decades is that we've seen other types of screen with lower measured open area values, but performed equally as well, both on bench scale experiments, on case studies where side-by-side full-scale wells are done. And so it just begs the question, well, if open area is not the issue that's driving the efficiency of the well, what other contributing factors are there? What's going on? Why would a 20% open area well screen and a 5% area open area well screen perform the same? And so I said, well, okay, what's going on here? We've looked at other studies saying, well, it's the combination of the gravel pack and the screen slot size. You do create turbulence as the water goes to a small amount radius around the well and as it approaches the screen and finally comes into the well. Those you just accept. Now, if you dissect that, say how much of that turbulent losses can we attribute to the filter pack and how much can be due to the screen, it's really a difficult task to do. What this model that we looked at said, okay, can you help, can the model developers, can they look at and help us calculate how much drawdown is, or how much to the total drawdown is contributed by the aquifer, the damage zone, which is the zone between the aquifer and the filter pack that you've just installed, and the screen itself. What are the different losses along the way? And it also provided an idea of what happens when the water actually breaks through the plane of different geometries of screen, a louvered screen, a slotted screen, a wire wrap screen, and a bridge slot screen. This is something we haven't seen before. What the model allowed us to do, if I just talk a little bit about just the water moving through the different screen types. As water moves through, unlike a pipe, what you'll find in these cases when you're using a screen, a large amount of volume of water coming through, on the back side of the screen, that is on the inside of the well, eddies are formed. So the water comes in under pressure, it's being pulled in, and then there's drag. There's drag as that water comes through that slot of any of those types. What the model did was actually create flow lines. It allowed us to see flow lines of how molecules of water would come in and how they would react, where those and how those eddies are formed. So for each of the four types, we saw, well, and it was kind of eye-opening how it performs for each of the different screen types. So that was a nice visual. It gave us an idea of like, okay. And after looking at different entrance velocities, different filter packs, different slot sizes, we asked the model, or put the challenge to the model, okay, measure the head loss on both sides of a screen that's gravel packed, and what can you assign to that screen's value for efficiency? And what we found was, regardless of the slot size, you were still at values of head loss, that is inches or feet of drawdown. The answers were very small for all the screen types that we looked at. So it helped us evaluate what specific products we market, which is a wire wrap screen and louvered screen. And people ask us, well, won't I get more water from your higher up your wire wrap screen? We say, not necessarily. It says we have results now that demonstrate, as well as the prior work that's been done, that both types of screens can work equally when installed, constructed, and designed properly. And again, maintained properly once they've been in. So the study was very was very eye-opening in one way, that let us see when I talk about these formation of the eddies and these also water jets as it enters the well. One surprising thing it did show to us is that the inwardly opening wire wrap screen, for example, showed from the sample we used for our wire wrap, the jets come in horizontally and then have to transfer to a vertical component as they move their way up to the pump. On a louvered screen, because of the geometry of the opening, it's upward facing. So therefore, the water is facing already in the direction when it enters towards the pump. So it looked like there's less turbulence inside the zone, inside the screen body, actually, because of the orientation of just the way it enters. And so it leads you to think, well, is that part of the reason why they operate the same? Is there turbulence on the internal side of, say, of one type of screen just because of the geometry versus another type, and that's how they equal? The upward-facing jets, less amount of turbulence versus the internal one that has to come in horizontally and move upwards. So again, they gave us velocity profiles that demonstrated that. So that's really what the AMPHO study allows us to do, is to interpret data that you couldn't see or you couldn't intrinsically figure out with formulas, for example. So that why it was very important. It's a very good contribution, and we also consider, I want to make this point, that study is just a step in a progression of steps in our understanding of how gravel packs and screens work in tandem to create higher well efficiencies. And that we hope sometime in the future there'll be more research done on that side, that we figure we just turned a page and we've run our lap, but it'd be nice if the next group of researchers could take that and then move that further along too, so they can really study more about what goes on in the inside of the well and the screens once the water's already in.